Okay. So good afternoon, everybody. Today I'm gonna complete RTI here. Yeah. So I already explained RTI. I told you RTI is a timer, right? Just let me maximize this one. Okay. So I told you guys RTI is a timer, and this timer should trigger interrupt from the microprocessor, should trigger the interrupt of the microprocessor every fixed time. So for example, if I set, that's what we call timeout. Timeout. Okay. So if I set the time here, for example, every 10 millisecond, so what's gonna happen is that this timer RTI is gonna interrupt microprocessor every 10 millisecond, right? 10 millisecond. Someone can ask me, yeah, this looks, that means you, every 10 milliseconds, the subroutine, the interrupt subroutine should be executed, right? This is how it works. Someone can ask me, okay, but how this can be useful? Okay, very simple. It is useful if you want to do something frequently. Okay, I want to do something frequently. Like what? Like for example, I want to flash the LED. I want to do flashing. That means every 1 second, I I I, I need to I need to interrupt every 1 second so that I flip the LED here. So every 1 second, I'm gonna flip the LED. So this is something. This is just an example. How can we need frequent interrupts? Okay. And then I told you how can you program it, guys. Very easy. All what you have to do, number one, you have to use this org all the time. Yes, all the time. Number two, I told you in order to program to set the time out, you have to write this one here. You have to write some number to this register RTI CTL. And I told you can get the number from the table here because actually this is RTI CTL and this is from here to here. That's what we call N. And from here to here, that's what we call M, right? And this, as you see here in this table, I give you all the values for M. I give you all the values for N, and then you can select whatever time you want. But anyway, the time here, this is this value is in the table, so you have to divide it by 8 to give you the time in microsecond. So if you divide this one by 8, this gives you the time in microsecond. So the time here, so if you use, that means if you put M 100 and you put N 1001, you are going to get interrupt every 10.24 millisecond. So that's what you have to write here. Okay. Usually, I don't want to complicate it. I know it's not easy to set the time. Yes, because you have to select numbers from this table. But I told you in chapter 5 we have a timer system. This timer system can be used for you can set the time in a more flexible way, much better than here. Okay, anyway, so I can tell you most of the time we're not going to need more than these 3 times. So this one we can use it, this one we can use it, and also if you want this small one you can use it as well, right? So all the time we're going to use these 3. If you want to use any other one, that's okay. But I think for the purpose of this course, these 3 should be enough, right? So, for example, if I want to set the time here, if I want to set the time 131 millisecond, that means M has to be 111 and N has to be 111. Okay, so you have here to put 111, 1111, which is F7F, right? Because this is a 0 here all the time. That's all what you have to do. Very simple. Just you have to get a number and then you have to write it in this register. Very simple. This is how can you set the time. Also, I told you any interrupt, I have to tell you where is the enable bit, right? This is the bit where you can enable or disable interrupts, right? So the enable bit here in CRGINT register, this register, this is a bit number 7. This is the enable bit. That means if you want to enable RTI interrupts, you have to put 1 here using bit set, as you see here. Okay. If you want to disable RTI interrupts, so you have to put 0 here, right? So using bit clear, bit clear. Okay. One more thing, guys. What do you mean by enable and what you mean by disable? Very simple. I'm going to tell you what I mean. Very simple. What RTI is doing, right? RTI generates frequent interrupts, right? If RTI is enabled. So if RTI is enabled, you generate frequent interrupts this way, right? However, if RTI is disabled, so no interrupts. Okay. So if you are using these interrupts, for example, to make a flashing LED, right? So if you want to stop the flashing, all what you have to do is just to disable the interrupts. Okay. So this is one thing. The other thing I told you, for any interrupt, I have to tell you where is the interrupt flag bit. This one. This is the flag bit. Okay. So the timer to trigger interrupt, the timer is gonna put 1 here, right? And as I told you before, you have to clear it in the interrupt subroutine. You have to clear it. So it is in this register, right? So you have to write this. You have to write this one all the time. All the time in the interrupt subroutine of Rti, you have to write this one in order to cancel the interrupt, because you already served it, right? So that's what you have to do. Now I want to explain. Already I told you before, several programs I taught in chapter 3, right? I'm gonna repeat them here in chapter 4, but the difference is in chapter 3 I wrote the programs in the main program part, right? Now I'm gonna do the same task, but it's not in the main program, but I'm gonna do it using interrupts. Okay. And that's what I said before. Any program should have a number of tasks, right? And you are the one, you are a programmer, you are a designer, you have to decide where you have to write every task, right? uh, so you can put one task in one interrupt. You can put another task in the main program. That's why I'm showing you here, or I want to tell you here what we did in chapter 3. We can do the same thing, but using interrupts. So now the main program is free. You can put whatever you want, another task in the main program. So what I want to do right now, I want to do flashing LED. So as we did in chapter 3, I'm going to turn the LED on for 1 second, off for 1 second. Okay. So the way but here this time I want to do it using RTI. Okay. So the way you are going to do is as follows. Look here, guys. So I'm going to generate interrupts every 1 second, right? So this is every 1 second, every 1 second. And now I have interrupt subroutine. This subroutine is gonna, this is interrupt subroutine for RTI underscore interrupt subroutine is here. So this subroutine is gonna be executed every 1 second, right? It's very easy. And then all what I have to write here in this subroutine, right? Number 1, don't forget, you have to clear the flag bit all the time. You have to do this. So number 1, you have to clear the flag bit. Number 2, I'm gonna XOR, I'm gonna flip XOR the LED pin bit. Okay, so I'm gonna flip the bit so that if the LED is on, I'm gonna make it off. So here I'm gonna flip the LED every 1 second. Very simple. You have a subroutine. This subroutine is executed every 1 second. Every 1 second, you are gonna flip the LED. Very, very easy, very smart, very interesting. Why it is very interesting? Because, and this is the main point here, guys, the 1 second here is not gonna be counted by the microcontroller or microprocessor, right? This 1 second is going to be counted by the timer. Okay, this is completely different from what we did in chapter 3. Chapter 3, the CPU had to count, or it had to run some instruction for 1 second. Is that okay? It looks a very interesting idea. What you did, yeah, it looks great. However, there is a problem. What is the problem? I cannot generate interrupts every 1 second. This is a very long time, right? Based on the table, I explained right now. If you look at this table, the table that has all the possible timeouts, the maximum timeout you can get is 131 millisecond. I cannot zero, I think seven something. So it's around 131 millisecond, right? So I cannot trigger interrupts every 1 second, right? So what can I do? Very simple. What I'm gonna do is the following, guys. Here I'm gonna count. So this is interrupt number one. Okay, so interrupt number one is gonna come after 131 millisecond. Interrupt number two, another 131 millisecond. Interrupt number three, another 131 millisecond, until interrupt number eight, right? At interrupt number one, I'm not gonna do anything. Just once I come to the subroutine, okay, are you is this interrupt, okay, less than eight? Just leave, do nothing, right? Because it's not 1 second yet. At interrupt number eight, now it is 1 second. Why? Because if you multiply 8 times 131 millisecond, it's going to give you around 1 second. Is that clear, guys? Very easy idea. I'm going to have interperiodic interrupts, okay, as you see here. But I'm just gonna count this interrupt number one, interrupt number two, interrupt number three, and so on. But I'm gonna take action every 8 interrupts, because eight interrupts means 1 second, right? Now, using the same concept, using the same idea, right? If I wanna do flashing every half second, right? So what should I do? Okay, very easy. I'm gonna take action every 4 interrupts, because 4 interrupts means half a second. Very easy, right? Also, same thing. If you wanna make flashing every quarter, so quarter actually should be 2, every two interrupts. Is that okay? Any question, guys? Okay, so I'm gonna show you how I programmed it. Very simple, very easy. Okay, so here, guys, yeah, this is the program. Here in the program, as you see, for sure I have to write this one, as I told you before. This one, initialization, I have to tell microcontroller where is your program. Also, because I'm using LEDs, so this is similar to what we did before. You should configure port J, right? Because J is used to enable LEDs, and also you have to enable LEDs. Also, you have to configure port B, right? Also, you have to configure port P, because this port is used if you want to disable 7 segments. So nothing here is new, right? This is the main program. I just do the initialization in the main program. After that, I have to set the RTI rate, right? Which here I put 7F in this one. 7F should generate interrupts every 131 millisecond. Is that okay? And then here, I'm going to enable interrupts here. Enable RTI interrupts, very easy. And then I'm gonna enable all interrupts. So what I did so far, just initialization, right? Once I finish the initialization, now the interrupt is gonna work. So once you finish all the initialization until here, now interrupts are working. Okay, that means now I have a subroutine. This subroutine should be called every 131 milliseconds. Is that okay? And now this is the main program, because here I'm doing only one task in this program. The main program is free, is empty. I'm not doing anything. I'm gonna keep looping here. So what's gonna happen, guys, is we're gonna keep looping here, as you see here, guys. And then every 131, you are gonna go execute a subroutine and come back, right? This should happen every 131 millisecond, right? Some students are confused here. So we don't call the subroutine, guys. In interrupts, you don't call interrupts, right? Already you have a timer. The timer is going to take care of that. The timer is going to trigger interrupts every 131 millisecond. So you don't need to write an instruction to call the interrupt, right? Again, what I'm saying now, guys, the main program is free. So if you have another task, you can simply remove this one and just write your task here, right? But this is just a simple program. I just want to program flashing LED. Any question about the programming? Very easy. Once you do this initialization, guys, the interrupt should work. And now I have interrupt subroutine here. This one, Okay, and then you have to end it with RTI, as I said, and then write whatever you want to write here. Okay, so whatever you write here, guys, this one should be executed every 131 millisecond, right? So let's see what in this program, what should I write here? Okay, number one, you have to clear the flag bit, right? I told you we always, for any interrupt, we have to do this one, except there is only one exception, IRQ. In IRQ, this is done automatically, but for any other interrupts, you have to write this one, right? This number one. Number two, now here I define a variable. This variable, I call it Rti count, because as I told you before, I'm gonna count. This is interrupt number one, interrupt number two, interrupt number three. We need to count. That's what I did here. Look here, guys. So here I'm gonna say increment Rti count. So here and now I'm gonna compare the count to 8, as I told you before. If it is not 8, what should I do? Just come here to leave. Do nothing, right? So if Rti count is not 8, that means it is 1, 2, 3 until 7. That means it is not 1 second yet. So I'm gonna just jump here to Rti, just leave, right? So once it is 8, I'm gonna come here. So every 8 interrupts, I'm gonna come here. So every 8 interrupts, what should I do? As I told you before, you need to flip the LED. That's what I did here. I flip the LED, right? Number two, I have to clear the counter. As you see here, guys, I have to clear the counter so that I count for another 8, right? So here we count to 8, right? And then we count another 8 and so on, right? So here you have to clear it so that you count for another 8. Is that clear, guys? Any question? Okay. I want to tell you something very important, very, very important. Please, guys, listen to me, because you may make it and you run your program is gonna run, but it's error. Okay, you don't know where is the mistake. You may spend hours looking for the mistake. Okay, so listen to me. What I'm saying here, the counter I'm using here, it has to be a memory location. It cannot be a register. Very important. So it has to be a memory location. I cannot use, for example, increment register A or register B. You cannot. Why? Why? Because as I explained before, guys, in the interrupts, once there is an interrupt, all the registers are going to be pushed to stack, and all of them are pulled back from stack automatically. You don't need to do anything here. That means when you increment register A, right, after you return here, register is going to take the initial value again, right? So if A starts with 1, it's going to continue 1 all the time, right? So it's gonna continue 1 all the time, because it does not hold, or registers don't hold or store their values, right? Because this Rti is gonna when the interrupt is triggered, all the registers are pushed to stack, and Rti is gonna get the initial value back. Is that clear? That's why if you want to memorize, so interrupt subroutines here, don't memorize registers values, because what I said before. Okay, guys? So if you want to memorize some value, you have to use a memory location. Any question, guys? Okay, let me ask you a question. Now, if I want to do flashing every half a second, very simple. All what you have to do, just remove this one, guys, here, and put 4 here. That's it. So once you put 4 here, that means you are going to trigger interrupts every 4 interrupts. Very easy, right? Or you can write 2, so that you can trigger interrupts every 2. Sorry, I'm sorry. Here, when you put 4, you actually are going to flip the LED every 4 interrupts. When you put here 2, you are going to flip the LED every 2 interrupts. Okay, 2 interrupts means a quarter a second, and 4 interrupts means half a second. Okay, guys? This is just a very simple program. Here, I want to manipulate two LEDs. So one LED, I want to change it every 4 interrupts, and the other one, I want to change it, I want to flip it every 8 interrupts. So one of them should be faster. So that means you have 2 LEDs, right? This one is going to flash every 4 interrupts, means every half a second, but this one is going to flash every 1 second. So two LEDs are flashing, right? So it is a simple program. It's a simple program, but what I do here, guys, here, I'm going to look for 4. I'm going to compare with 4, right? And if it is equal to 4, So I'm gonna flip the first one. So this one has to be flipped every 4, right? Every 4 interrupts. That means this one has to be flipped at 4 and 8, right? 4 and 8, 4 and 8, right? So here, same thing here. Now, when it is 8, but when it is 8, I have to flip both of them. So both of them should be flipped every 8. That's why here I use number 3. 3 means 11000. So here you flip 2, right? So anyway, so if you look, very simple. All what I did here, guys, every 4 interrupts, when the count is equal to 4, I'm gonna flip this one only. But when the count is equal to 8, I'm gonna flip this one and this one, so that this LED is flipped or flashing every half a second, but this one every 1 second. Very simple program anyway. Okay, guys. Now, how can you do the same thing using C language? Okay, as I told you guys before, for C language, for interrupts in C language, all what you have to do, as I said in IRQ, it's exactly same thing. You have to put here the word void. This is a keyword. You have to put here the word interrupt. And then here you have to select a number, right, for this interrupt. In case of IRQ, remember, we used number 6 because 6 is used for IRQ. And I told you last time, how can you get this number? Now 7 is used for RTI, right? So that means I'm telling the C language, this is the interrupt subroutine for RTI, and then you can put e name, right? This is how can you, and now so this is the interrupt subroutine here, right? So once I set the time the time out, so this one is going to be called automatically, right? So now let's see what this is. The main program is here. The main program is here. Let's see what I wrote here, guys. Number one, I do initialization for the system. I disable 7 segment. I enable LEDs. Okay, and now we have a function. This function is called Rti Initialization. So this one is going to do the initialization again. You can open this function and you see how it is written in C language. Sorry, in assembly language. If you look at inside this function, you will find it has this part. It has this part as well. This one and this one. Okay, but here we use a different number, not this one. We use another number. I think it's 49. The number that trigger every 10 milliseconds. So if you use this one, guys, the default time out for this function is every 10.24 millisecond, right? Someone can ask me, okay, what if I want to change it? I want to make it like every 130. What can I do? You have one of two solution, guys. You can write this one here after the initialization. You can write it here, RTI equals 7F. You can put this way, right? Sometimes, in most of the cases, this one worked with us. However, in very rare cases, this one didn't work. So in this case, what we did, students, you can go inside this function and to change the assembly of this function. If you go inside this function, you will find this instruction here. But here, this one is 49, I guess. Okay. So you will find this one, and this is 49. You can just remove this one and write 7F. That's it. Okay. If you need, right? You may not need it. So anyway, so again, let's see how can you program RTI in C language. All what you have to do, guys, just write this one. You are good to go, right? So it's you already now it is good, right? So now it can work, right? Again, if you want to make the time, but this is a default here. You are gonna make interrupt every 10 millisecond, right? And that's it. So very simple. So now this one is going to be called every 10 millisecond. And again, because the main program, because here I program only one task, not 2 tasks. You can see here the main program is empty, right? So if you have another task, you can put it here, right? So all the time there is a looping here. Every 10 millisecond, I'm going to go execute this one and come back. Every 10 millisecond, go and come back, okay? Now, let's see what should we write here. Because now we have interrupt every 10 millisecond, guys. So same idea as I did before. I need to count the interrupts, but this time you have to flip the LED every 97 interrupts, because if you multiply 97 by 10.24, right, you get 1 second. Is that okay? Just give me 1 second. I'm trying. Yeah. So here, same thing as before, but what we did before, I counted only 8 interrupts, right? I have to flip every 8 interrupts. This time, it is every 97. So if you see here, guys, what I did here, as you see, in every interrupt, we have a variable. This variable is called tick. Okay, this variable, you see, I define this variable here, right? Initialize it with 0. Every interrupt, I'm going to increment this variable. And now, if this variable is equal to 97, right, I'm going to toggle the LED, right? And then I'm going to put 0 in ticks in order to count for another 97. And then this is if it is 97. If it is not 97, just I'm going to leave, right? So before you leave again, you have to clear the Rti flag, right? In order to clear the Rti flag, what you have to do, you can just write this function in order to clear the flag. Someone can ask me, yeah, but in assembly you put it at the beginning, but here you put it at the end. Does it matter? No, it doesn't matter, right? What's important is you have to do it. It doesn't matter if you put it at the beginning or the end. It doesn't matter, because already, as I said before, once I come to the interrupt subroutine here, other interrupts are already disabled. You got what I'm saying? So it's not going to make any difference. Okay, unless, listen to me, but if you ask me about my advice, for most of the program should be okay. However, if you ask me for my advice, try to keep it in the beginning. You know why? I'm going to tell you why. Try to keep it in the beginning. You know why? I'm going to tell you why. Because in some cases, maybe you have a very quick interrupts, right? So that means maybe here, while I am here, another interrupt to come, right? In this case, I'm going to lose this interrupt. So if you clear, you have interrupt flag, but if you clear it in the beginning and then interrupt happen here, you are going to capture it, because now this one is 1, right? You can capture it. So after you leave, you are going to come back. Okay. So in most of the cases, it's not going to make a difference, as I said. However, maybe I think it's a good habit to put it at the beginning, just in case there are some very frequent interrupts. Okay. The last thing, very easy, right? So last thing I want to explain here, guys, this text, why I define it here, right? This variable. If you define this variable inside the interrupt subroutine, that's wrong. If you define it here, that's wrong, right? It has to be global. So you have to put outside here. You know why? I'm going to tell you why. Because if you define it here inside here, guys, once you leave the subroutine, it's going to be canceled, removed from memory, right? But if you put here outside, so even if you come here and leave, still it is there in the memory. Please, this is small mistakes. If you don't understand these things, you are going to make mistakes. You are going to waste a lot of time to figure out how can you fix it, right? So that's why I want you to pay attention to what I'm saying. What I'm saying, if you define this variable inside here, guys, once you leave, so this one is going to be local, it's going to be removed from memory. So when you come back, okay, so it's going to be like a new variable. So it's not going to keep the count. Okay. Any question, guys? Great. So what I'm going to do right now, guys, is I already explained a program now to do flashing LED, right? Flashing LED. I wanna add, in addition to RTI, I also want to use IRQ. Okay, so now I want to show you a program that is using RTI and IRQ, right? So RTI is going to do flashing. Okay, so now why you want to use IRQ? IRQ, as I said before, we are going to connect. So this is IRQ. You are going to connect. You are going to connect it to the push button, right? As I said last time, connect it to the push button, so that every time you press the push button, you trigger interrupt. Okay, so every time I press the push button, I trigger interrupt. Is that okay? And now what I want to do, IRQ, I want to use IRQ to turn flashing on and off, right? So when if flashing is on, I press IRQ, flashing is off. If flashing is off, you press IRQ, you turn on flashing. Is that okay? That's great. So how can you do that? I'm going to tell you how. Very simple. Look here, guys. So now I'm gonna take exactly same program. I'm not gonna change anything in this program. I'm gonna just add IRQ to this program. And in IRQ subroutine, okay, what I'm gonna do, there is one bit for enable, right? Enable bit. All what I'm gonna do, I'm gonna toggle this bit. That's it. That's it. Why? Because this is for RTI, guys. So this is the enable bit for RTI. So that every time I toggle it, so that if RTI interrupts are enabled, I'm gonna disable. If they are disabled, I'm gonna enable them when you toggle, right? That's why every time you press, it's gonna enabled goes to disabled, disabled goes to enabled, right? Someone can ask me, but this, do you think this gonna stop the flashing? For sure. For sure, this is gonna stop the flashing, because who is making the flashing? Who is making this subroutine is making the flashing, right? Because we call this subroutine, that's how we make flashing, right? So if RTI interrupts are disabled, that means you are not gonna call this subroutine. That means there is no flashing, right? Again, very simple. As a rule, this is a rule. If you have a task, this task is run by a interrupt subroutine. If you want to stop this task, all what you have to do, just disable the interrupt, this interrupt subroutine, right? That's what I'm going to do right now. Any question, guys? Okay, let me choose a program. So this program is exactly similar to program I have taught right now, guys. The only difference, I'm going to show what I added here. So I have to add this one for IRQ. So now, guys, I have two. I have one here for RTI, and I have to add another one for IRQ. That's easy, right? This is number one. Number two, I already have the configuration for RTI. Now I'm going to add the configuration for IRQ, right? This is this configuration. That's it, right? And now RTI is exactly the same, okay? That means, guys, all the time I'm here, if there is interrupt from RTI, I'm going to go execute RTI subroutine and come back, right? Or if there is interrupt from IRQ, I'm going to go execute IRQ subroutine and come back. That's it, right? So RTI is going to be the same thing as explained before. Now let's look at IRQ, how you are going to make IRQ. The first part here is debouncing, as we did before, and that's what I told you guys now. Yes. So I already know in this register, CRGINT, in this register, bit number 7, this is the bit enable bit, right? So what I'm going to do, I'm going to read this register. I'm going to toggle every time you press a button, I'm going to toggle this bit, right? And then store it back, toggle it, okay? Because if this bit is 1, you enable RTI. If it is this 0, you disable RTI, right? Any question, guys? Very easy, very simple, right? Any question? Okay. C language, how can we do the same thing in C language? I'm going to show you right now, okay? So in C language, now here I have to write this one to initialize our configuration for IRQ. I have to write this one as well to configure RTI. So I just added this one to the previous program, right? Then now I have two interrupt subroutine. One is number 7. This is for RTI, and one is number 6. This is for IRQ, right? So this is IRQ. For here RTI, this is similar to what I explained before. No difference. You need to count for 97 interrupts, right? And toggle every 97. Very easy, right? Now, for IRQ, I need to toggle, right? So the way I'm going to toggle it, you can use the same idea as you can use this idea, flip the bit. But here I'm going to do it in a different way, little bit. So here I created a variable. This variable, I'm going to call it status, right? So this variable can tell me if RTI interrupts are on or off. Okay, so that if it is on, I'm going to make it off. If it is off, I'm going to make it on. So this variable should have one of two values. This is similar to the variable you used in the last lab. If you want to know if the LCD is on or off, right? You use the variable. Same thing here. Okay. So here, this variable should have value 0 or 1. Okay, one for on and the other one for off. 0 for off and 1 for off. Look here, guys, what I did. If status equal to 0, right? That means it is off. RTI is off. So I'm gonna go and enable RTI. To enable RTI, you can use this function, or you can use the same idea I used here in assembly, flip the bit, but you already have a function, you can use it, right? And now also, because now I made it on, so now I'm gonna status now is 1, right? So that next time when you press the button, now I'm gonna come here, right? I'm gonna put 0 here in status, and then I'm gonna disable it. So you know how it works, guys? It works as follows. When you press the button one time, you come here, one time. Next time you come here. Next time you here. Next time you here. So every time you press one time, the button, one time here, next time here, one time here, next time here. You know why? Because every time I change the status, now status is 0, I'm here, right? And then I make it 1, so that next time I come to here, right? And so on. Any question, guys? So here I use a variable called status. Now, if it is off, I'm gonna make it on, right? If it is on, I'm gonna make it off. Easy, easy. Any question, guys? Okay. Now, there is one part in chapter 3, which is a 7 segment. I didn't teach it, so I'm gonna go to chapter 3 now. The good thing is, I'm gonna explain a program in chapter 3, and then I'm gonna come now, I show you how can we do the same thing using RTI. So in chapter 3, I'm gonna do it in the main program. Here, I'm gonna do it in so it is really, it's a good idea to teach the same program at the same time. One time I want to show you that this program, I can put it in the main, or I can put it here in RTI as well. So now I'm going to move to chapter 3 to explain how can you program the 7 segment. Very easy. It's nothing almost new. So everything is similar to what I did before. So let me come here. Yes. So look here, guys. As you see here, guys, on the Dragon board, we have four 7 segment, as you see here, right? I told you before, if you remember, these 4 7 segment and the LEDs are connected to port B, right? Port B. That's why if you wanna, if all of them are enabled, if you write something here, it's gonna be shown here, shown here, shown here, shown here, right? Because all of them, if all of them are enabled, that's why we don't do that, right? I told you before, what we do, this one has enabled BG1, if you remember. This one has PB0, PB1, PB2, PB3, right? So usually we only turn one at a time, only, right? So for example, if I wanna use this 7 segment, I'm gonna put here 0. I have to make sure everyone else is 1, right? To disable it. Or if you wanna use this one, you have, so this is 0, so I have to make sure everyone else is 1, and so on. So now I'm gonna explain how can we program this 7 segment, right? So it's easy. It's similar to the LEDs, no big difference, as you will see right now. Yeah. So first of all, why it is called 7 segment? Because if you see here, guys, we have 7 segment here. This segment is called segment A, segment B, segment C, segment D, segment E, segment F and G, and we have a dot here as well, right? So total, they are 8, but segment are 7, right? So, but total are 8. Every segment here is an LED. Every segment is an LED. Is that okay? So they look like something like that. So they look like the LEDs I explained to you before. Look here, guys. So this is, for example, segment A, and then segment B, right? And so on, right? Until H, right? All of them here are connected to PP0. PP0 to from PP0 to PP3, as I told you, right? PP0. So if I put here 0 in PP0, it is enabled, and they are connected here to port B, right? So if I put here 1, I turn on. If you put 0, you turn this segment off, and so on. Very easy. So number 1, as a hardware, as a structure, it's exactly similar to LEDs, exactly same thing, right? Let me go back to LEDs because it's exactly similar to this one. However, instead of BG1, this one again use PB0 to PB3. Also, Every LED here is a segment. So you can turn this segment on if you put 1, you can turn this segment off if you put 0, and so on. And by turning some segments on and some segments off, you can make shapes, like shape number 7, you can make number 3, you can make digits, numbers, as you will see right now. Okay. Yeah. So look at this table, guys. Okay. Here, if I want to display number 0, so which segment I have to turn on, right? So I have to turn all of them on, right? Except G, right? And H for sure, right? So G is off, right? So how can you do that? As you see here, guys, this is port. This is the value I have to put in port B. So I have to put here 1, 1. All of them are 1 except G is 0, right? So and this number is 3F. So now, if I want to display number 0, I have to send the 3F to port B. Yes, that's true, right? Now let's see another digit. If you look at number 1, if you want to display number 1, guys, so if you see here, I'm gonna, all of them are off except C and B. So here, this is number 1. Everything else is off. So this is the number you have to send to port B, right? And so on. So now, for example, let's have another number 9. So if you want to make 9, so I have to turn all of them on except E, right? So this is the only one that's off. Everyone else should be on, right? So I have to use this code. So yes. So you should use this code. Okay, very easy. If I want to display number 7 here, I have by accident 7, you have to send 7 just by accident, right? If you want to display number 6, you have to send 7G to port B, right? Very easy. So let me tell you the conclusion. Very easy conclusion. Number 1, guys, we have 7 segments. We have 4 of them. All of them are connected to port B, right? This one has enabled BB0, BB1, BB2, BB3, and so on, right? So if I want to use the first one, I'm going to put here 0, and then I'm going to put 1, 1, 1, right? So now this one is working. These ones are not working, right? Exactly similar to the idea of the LEDs. When you put here 1, which is 5 volt, you turn them off, right? Anyway, so now this one is working. Now, if I want to display any digit here, I have to take a value from this table. I have to put it in port B. Very easy, right, guys? Any question? Okay. Any question, guys? Okay. So now I'm going to show a program. I want to make a counter, right? So I'm going to make here, I want to use 7 segment. I need to count from 0 to 9 and then repeat 0 again to 9, right? So let me choose a program first before, sorry, let me choose a video to understand better what I mean before I, videos, counting 7 segment. Yeah, I think this one. Let's see this program. This is a 7 segment program. So let's run it. Wow. Yes, I have to. Look here, guys. Counting 1, 2, 3, 4, 5, 6, 7, and so on. Not 8, 9. After 9, it should come 0 again and count again, right? So here the speed of the counting is 1 second. So it's 1 for 1 second, 2 for 1 second, 3 for 1 second, and so on. So I'm going to explain how can we do this program, guys. Okay. Yeah. This is the program here. Okay. So look at the main idea now. Number 1, I have to create a table, as you see here. So I created an array or table with the code. This is the code that is in this table here. I just put this code, right? So that if you want to display 0, I have to get this one. This is for 0, this is for 1, this is for 2, all the way until 9, right? And then after that, I have to do configuration, right? So here in configuration, guys, you have to program port B and port P and port J, all of them output. Also, you have to make sure you disable LEDs by bit set here. Before we used bit clear, now we are using bit set, right? Also, you have to make sure you enable only one display. That's why here I'm using number EF, because EF is actually 011, right? Uh, so yeah, right. So that's why here I put 0 in order to enable display 0. So this part is just initialization. Now the program start here. Look here, guys. Look at the idea. Look what I'm gonna do. First of all, I'm gonna use a pointer register X. Register X is pointing on this value. I'm gonna take this value. I'm gonna send it to port B, and then I'm gonna wait 1 second. Is that okay? After that, I'm going to increment X. I'm going to take this value, send to port B, and then I'm going to wait 1 second. After that, I'm going to increment X, take this value, send it to port B, wait 1 second, and so on, until I come here. Once X come to here, I have to go back to the beginning again, right? That's exactly what I'm going to do. So let's see how I did it. Look here, guys. Here, X is pointing at the beginning, right? So X is here, very beginning, right? Okay. And now I'm going to move a byte. I'm going to copy a byte pointed by X to port B. So I'm going to take this one, send it to port B, as you see here, right? Then I'm going to wait 1 second. Wait 1 second. Is that okay? Increment X for sure. I have to increment X. Now I increment X, and then I'm going to wait 1 second. Okay. Now I have to check if I came here or not. I finish all of them so that I come back or not, right? So what I did here, I'm going to compare. If I come until here, so X should equal the beginning address plus 10, right? So if X is equal the beginning address plus 10, I have to be here, right? So that's what I'm doing here. So I'm going to compare X to the beginning address plus 10, right? If it is not equal, what should I do? I'm going to keep looping here, right? So I'm going to come here to take this value, display it. That means I'm going to keep looping here, guys, from here until here, okay? So you can see in every iteration, I'm going to get 1, send to port B, wait 1 second, send to port B, wait 1 second, send to port B, 1 second, right? And now, if it is not equal, now if it is equal, I'm going to come here, and this one is going to send to me to here to reinitialize X. So if I already come to the end here, so this loop is going to be taken so that I reinitialize X with the beginning address back. So that's why after 9, we're going to display 0. Any question, guys? Easy, right? Easy, easy, easy. Any question? I just take one by one. Once I come to the end here, I move to the beginning again to repeat again. Any question? Okay. How can you do the same thing in C language, right? I'm going to show you how. So I'm going to present you 2 ideas, and there is a reason why I want to present 2 ideas. I'm going to tell you right now, okay? So the first idea is very close to what I did right now in assembly, right? So as you see here, I created an array. This array has the code, right? So this is for number 0, number 1, number 2, until number 9, and that's what you have to send to port B, right? So that's very easy, okay? And now you need to disable LEDs. You have to enable 7 segments. That's okay. And now look here, guys. I'm gonna make full loop from 0 to 9. Okay. So here 0, I is equal to 0, I equal to 1, I equal to 2 until 9. Right. So that's why you can see full loop here. So I'm gonna repeat this part 10 times from 0 to 9. Right. When it is 0, see what I did here, guys. When it is 0, so I'm going to take the element 0, right? I'm going to put here. So this here is element number 0. And then here, I put 0. So what this means? So in every, let's explain this function. This function actually this function is called segment 7 on. So this function, whatever you put here, is going to put it on port B. So this is the first thing this function is doing. So this function, whatever is the first argument here, is going to go to port B. This is number 1. Number 2, because of this 0, this one, it means I'm gonna enable display 0, right? That means if you want to enable display 1, you can just put 1 here, or display 2, or it's display 3. But here, this one is fixed 0 because I want to display it on only one display. So here one display is on, 0 is on all the time. And now this one, I change this one based on the value of I. When I is 0, I'm gonna send this one to port B. When I is 1, when I is 2, when I is 3, when I is 4, until 9, right? So in every iteration also I have to wait 1 second, right? So here, look here, guys. So based on the value of I, I'm gonna take one element from here, I'm gonna send it to port B, and again display 0 is already enabled. So wait 1 second, go back and repeat. Any question, guys? Okay. So I'm gonna repeat the same program, but in another way. So let's very simple way. Look, what I did here, guys, I'm not gonna use a table. This table, I got rid of this table, but by using a different function. This function, yeah. So here, I'm not sure the arrows are not working. Previous, okay. As you see here, guys, we have another function. This function is called segment 7 decimal. So all what you have to do, guys, just to give me a number. Give me number 0, number 1, number 2, 3, whatever. And then inside this function is going to convert this number to a code, like these codes here. So it's going to convert to these codes, right? So you don't need to do this conversion by yourself. Just give a number to the function. The function is going to convert it, as you see here. So just give it a number and tell me which display. That's it. So here what I did, I just don't be confused. I just made it 500. You can make it 1,000 to be similar to the previous program. So this part has nothing to do with the function, right? You can just change this number because it was 1,000 before. You can keep it 1,000. So this function is very simple. Why? Because you don't need to do the conversion by yourself. You don't need to do the conversion from a digit, from a number to the code, 7-segment code, right? You don't need to do that because this is already done inside the function, right? So someone can ask me, okay, this is simple, very easy. So why you explain to us the previous one? Why? Right? So it would be enough just to do this one. The answer is no. I'm going to tell you why. This function, yes, it is simple, but this function can be only used if you want to display numbers from 0 to 9, right? This can be only used in this case, right, guys? Sometimes I use the 7-segment to display some letters, very little letters, like letter N, like letter H, letter O, O is 0, so it doesn't matter. So sometimes I use it to display some letters, right? So in this case, this function is not going to help you. So here you have to write the code. If you want to do something like that, so here you have to write the code for the letter. That's why I have to explain different ways, right? But my advice to you, if you ask me about my advice, my advice, just this one is very simple. If you want to display digit, you can just go for this one, use it this one all the time. Any question, guys? Okay, so what I explained so far, guys, I explained how can you use only one, let me go here. Okay, guys. So what I explained so far, I explained how can we use one 7-segment, right, to display one digit. Okay, someone can ask me, there is a problem. Yes, there is a problem. So what is the problem? The problem is you have four 7-segment. All of them are connected to port P, right? So whatever if all of them are enabled, if I write here the code 07, the code for 7, you are going to see 7777 because all of them take from port B, right? So someone can ask me, there is a problem because all of them are connected to port B. So how How can I display a number like, for example, 3725? How I can display more than one digit, right? I'm going to tell you how. There is a technique where I'm going to explain right now. This technique is called time multiplexing. Multiplexing, right? So I'm going to explain this technique right now about the main idea. But you should understand, because all of them are connected to port P, right? I have to enable one at a time, right? Because if I enable two, you are going to repeat the number. I don't want to do something like that. I want to display 3725, right? So it should be only one at a time. Yes, I'm going to tell you how. Look at the idea, guys. Now we have 4 7 segments. All of them are connected to port B, right? So now I want to display number 7 here, right? And then I'm going to enable this one, and these ones are disabled, right? So I can do that. I'm going to put the code for number 7 on port or 3, whatever it is, 7, any number, it doesn't matter, right? So 7. So now I enable this one. And then after a small delay, what I'm going to do, I'm going to disable this one. Now I'm going to put a number 3 here. I'm going to disable this one. I'm going to turn this one off, right? So here I'm going to put number 3 on port P, right? And then same thing after a small delay here, same thing, this one off, this one off. Then I'm going to do number 2, right? And this one is off here, number 2, right? And then after some delay, this one is off, this one is off, this one is off, and then I'm going to display number 1 here. Okay, guys? So at any time, only one displays on, because all of them are connected to port B, right, guys? However, and then I'm going to go repeat again, right? However, if I can do this very fast enough, if I do it fast enough, so you will see this number very stable. You are not going to notice that one of them on and the other is you are not going to notice this one off in this time slot. You're not going to see off. You are going to see very stable number, as you will see now in the video, right? If this delay is small enough, right? Okay. So this is the main idea. That's why we call it time multiplexing, right? This is the main idea. That's what we are going to do. But there are several questions here we need to answer. The first question, you told us we are looking for speed. Okay, you need to do it fast enough. So if you want to do it fast enough, why you put a delay here? Why you introduce a delay here? I'm going to tell you why. Look here, guys. What happens if I remove this delay? You know what happens if I remove this delay? So if you look at the 7 segments, they are going to become dim. You know why? Because if you look at the illumination, light, is that illumination, light, the power of the light, okay, something like that. And this is the time, okay, this is the time, and then when you apply the voltage, guys, to an LED, it takes some time to reach to the maximum brightness. That is why I cannot just put 5 volt and remove it quickly. So it's going to become dim, because you are going to be here or here, it become dim. So you have to keep the 5 volt. When you apply 5 volt you have to keep it for some time, okay? That's why we introduce a small delay here, right? This is the first question, why you need a delay here, right? We need a delay here so that I need to keep the voltage for some time so that LED can reach to the maximum brightness, right? Otherwise, it's going to become dim. That's why we need delay. Second part. Why? Okay, so what happens if this delay, you told us if this delay is too short is bad. Too short, bad. Why too short is bad? Because it's going to become dim, as I said. Also, too long is bad. Why too long is bad? Because if it is too long, you are going to see flicker. And I think I'm going to show you in the video right now. You are going to see flicker because I'm going to turn this one on and then I'm going to wait long time until I go back and turn it on again. You will see flicker. You are not going to see a stable number, right? So conclusion, you need a delay, but this delay should not be too short, okay, to avoid making the 7 segment dim. Also, it shouldn't be too long to avoid making flicker, okay? So if you see flicker, flicker, okay? If you see flicker, that means you have a long delay, okay, guys? So this is the first, this technique is called time multiplexing. Someone else can ask me why we overcomplicate it. This should be very simple. Okay, what you want to do? Okay, very simple. So I have a microcontroller. I can use all the problem, or why you are using time multiplexing here? Because all the 7 segments are connected to one port. All of them are connected only to one port, right? So very simple. I can use one port for 7 segment. I use another port for 7 segment. I use another one port for 7 segment, another port for another 7 segment, and I don't need to time multiplexing. Yes, that's true. You don't need to time multiplexing. Just to put here number 7, put here number 3, put here 2, put here 1, and you are happy. I'm happy. Everybody is happy, right? So you can keep it this way. I don't need time multiplexing. But there is a big problem now. What is the big problem? You already almost consumed, consumed a lot of ports. We don't have too many ports. You got what I'm saying? If only the 7 segment, if the 7 segment alone is going to take 4 ports, what if I want to connect a switch? I want to connect a push button, buzzer, whatever. You got what I'm saying? So that's why time multiplexing is interesting, right? Because we can use only one port. Any question, guys? So now I'm going to choose a program. How can we do this time multiplexing? Maybe I want to choose a video first. Which one here? Okay, multi-digit.
Yeah, let's run this program. If you look here, it's number 3, 4.
Yeah, maybe the camera is not very good, but you can see the number 3, 4, 5, 6. You can see the number is very stable, right? Very stable. Because the delay is when there is no dim, it's not dim because the delay is good delay. It's not too short, it's not too long. Now I'm gonna make the delay intentionally too long because I want you to see the flicker, to understand what I mean by flicker exactly.
4, 5, 8. You can see the number is 10. You can see the number is stable. However, this is because look here at the delay. What delay we have? The delay is only 5 millisecond.
Cool.
Look
Here I used the delay 5 millisecond. It was okay. It was not dim. There was no flicker. Now I'm going to increase the delay. You will see what's going to happen.
If we increase the delay, what may happen? You will not see a stable number. For example, let's try 100. So now we turn one display on for 100 milliseconds. Let's try.
So I turn it on for 100 millisecond, okay, and then it has to wait until I turn the second one for 100, and then third one for 100, and fourth one for 100 to come back to it. So it has to wait long time until I turn it on again. That's why you see it's gonna be doing like flicker or flashing.
What may happen? Look, wow, look here. Now you can see
flicker, right?
How the displays tricks us. So you can see only one.
Okay, guys. So you can see now
flicker. One display.
So now we can notice that only one on at a time. So now you can notice it, right? I think I was playing. I just changed the number. Let me see what I did here. Yeah, now it was 100. I was playing, so I just tried 50 to see if it still there is a flicker at 50 or not, right? 5 was okay. 5 millisecond was okay. 100 was bad. Let's see 50. I'm just playing, right? So yeah, still you can see flicker. It's faster than before, but still 50 is not good, right? So anyway, I think 5 millisecond is okay. Again, if you see flicker in your program, that means the delay is too long, right? If it is dim, that means the delay is too short, okay? So now I'm going to show a program. How can we do this? How can we display multi-digit or multiple digit at the same time? So look here at the idea, guys. Okay, I want to display this number as shown here. Very simple. I want to display this number, guys. 3, 4, 5, 6. 3, 4, 5, 6. Okay. So what's going to happen is that in order to display 3, I have to send this number to port B because this is the code for 3, right? Also, I have to send this number to port P because this number E actually is 1110 because I want to display this one on display number 0, right? So I have to send to two values, this value to port B and this value to port P, right? And then I have to wait a small time, as I said, short time. After that, I'm gonna move to number 4. So I'm gonna send this one to port B, and then I'm gonna send this one to port P, right? Because this one actually is 1011. So here I'm going to enable another display and so on. Same thing for 5. I have to send this one to port B. I have to send this one to port P. And this one actually is 1011, right? Same thing for number 6. If you want to display number 6, you have to send this one to port B. And you have to send this one to port P because this one actually is 1110. Okay, guys? So all what I'm going to do right now, very simple. All what I'm going to do, I'm going to make array and I'm going to make iteration. I'm going to make a loop. I'm going to then go back to loop. I'm going to make a loop, right? In every iteration, I'm going to take two values, one value to port B, one value to port P. Wait some time. Next iteration, I'm going to work on the second one and so on. So let's see how I made it. Number 1, as you see here, guys, I created array this way, as you see here, right? So what I'm going to do right now is in one iteration, I'm going to take these two values in one iteration. Next iteration, I'm going to take these two. Next iteration, right? And then when I take this one, I'm going to send the first one to port B and this one to port P to enable only one, right? As you see right now. And then once I come to the end here, I have to go the beginning again because I have to repeat. That's what I did. So here in the first part, I'm not going to explain it. This is just easy. This you here, you configure port B, port P, port J, and also you have to disable LEDs as well, right? And now let's see this program start from here. Here, look here, guys. X, register X is pointing on the first element here. This is the initial value for X, right? And then look here, I'm gonna take the one value pointed by X, I'm gonna send it to port B. This one to port B. And then I'm gonna increment X. So now X is here, right? And then I'm gonna take one value pointed by X, I'm gonna send it to port P, as you see here. Sorry, this one, go to port P, right? And then increment X. So now X is gonna be here. This is in next iteration, X is here, right? To repeat again, next iteration, right? So every time I have to wait, one, here I made it 1 millisecond. 1 millisecond, it was okay. In the video, 5 millisecond was okay. So you can make it 5 millisecond, right? And then now here, once I come to the end here, and I'm going to come to the end here, if the X is equal to the beginning address plus 8, because this is 0, 1, 2, 3, 4, 5, 6, 8. Okay. Sorry, 0, right? 1, 2, 3, 4, 5, 6, 7, 8. So once, and that's what I did here. Look here, guys. Compare. Here I compared X to this value. Okay. If it is not equal, so I'm going to come to here. If it is equal, I'm going to come here to reinitialize X again. So once I come, look here, guys. So once I come here, so now I need to reinitialize. I have to come to back here. This is going to happen here, right? So if it is not equal, if it is equal, so I'm going to come here and this one is going to bring me to here to reinitialize again. But if it is equal, I'm going to keep looping here, right? So let me summarize what I did, guys, here. What I did is, this is one iteration, second iteration, and then I go back to repeat again, right? So in every iteration, I take one value pointed by X, send to port B, increment X. Take this one, send to port P, increment X, and wait 1 second, 1 millisecond or 10 millisecond, and so on. So very easy, right? Now, how can you do the same thing using C language, right? So as you see here, very easy. Here, these are the four digit I want to display. I want to display 3, 4, 5, 6, right? So look how I made it here. I'm gonna use segment 7 decimal function. Remember, in this function, you don't need to convert the number to 7 segment code. You don't need. Just give me a number here. So in the beginning, when I is equal to 0, right? So I'm gonna get 3 here. I'm gonna put here 3, right? And which digit? Digit 0, right? So 3 is gonna be displayed on digit 0. Remember how this function works, guys? Just give a number here. This is the number you want to display and tell me which display. So this should happen in the first iteration when I is equal to 0. Okay. And then I'm going to wait 5 milliseconds. Now let's look at the second iteration. When let's use a different color. Use a different color. Yes. Second iteration here, when I is equal to 1. When I equal to 1, now I'm going to display this one on display number 1. Here, this one is 1. So I'm going to get it from here, right? I'm going to get number 4 here, right? Now in next iteration, when let's use another color. I love colors. So here, let's do it, for example, when I is equal to 2. So now this one is going to go to display 2. And then now I'm going to take the element number 2 is going to go here and so on. So here, I'm going to repeat this one 4 times from 0. So I here is going to take a value from 0 until 3, right? And then it's going to again from 0 to 3 because this is infinite loop, right? So I'm going to repeat this one forever. And here, this one is going to be repeated 4 times from 0 to 3. Any question, guys? Great. So you know what I explained right now? I'm going to repeat it again right now. But instead of writing them this way in the main program, I'm going to write them in RTI. You got what I'm saying? That's why I told you, if you have a task, time multiplexing task, if you want to do time multiplexing, you can put it in the main program, or you can put it in RTI so that you can write something else in the main program, right? So that's what I'm going to explain right now. I'm going to explain how can you do. I'm going to repeat everything I explained right now, but using RTI. Okay. So now let's start with the first program here. The first program, I want to make a counter. This is a counter I explained. You count only, you are using only one display. You want to count from 0 to 9 and then 0 to 9 again and so on, right? So let's see how I made it. Again, I'm going to do it in RTI, right? And I want to do flash. I want to change the number every 1 second. This is the easy part. Every 1 second, this is the easy part. You know why? Because I already explained how can you make 1 second, right? So all what you have to do is, I'm going to count. So here I have a variable here, this variable, this one should count interrupt 1, interrupt 2, and so on. So every 8 interrupts, so here I have some interrupts here. So every 8 interrupts, I'm going to display one number. So I'm going to take this one, right? Display it. And then after 8 interrupts, which is 1 second, I'm going to display this one. After 8 interrupts, I'm going to display this one, I'm going to display this one, and so on, right? So how you are going to display them? I'm going to tell you how. So what I did in the program, I used to register X, right? And every time I increment X, right? You cannot use X here, please, guys. Listen to me. You cannot use X here in the interrupt subroutine. Why? Because once you leave the interrupt subroutine, X is going to take the initial value back. You have to find another way, right? It was okay in the main program to use X, but now you cannot use X, right? Because it's going to be canceled. The value of X is going to be canceled, right? So I'm going to do it in a different way. So the way I'm going to do it, I'm going to make like something we call count. So this count should be 0. I'm going to add the beginning address to count to get the address of the digit I want to display. So in the beginning, count is equal to 0 to display this one, right? After I display this one, count is 1, count is 2, count is 3. So count is going to be like a shift. You remember when we did A comma X, something like that? A can be a count, right? X is a beginning address. A is a shift or count, right? And once count to come to here, I'm going to make it back to 0. Very easy, right? So you will see how I made it. So I'm not gonna talk about the programming. because nothing is new. This is exactly the same configuration I did before. Nothing is new. Okay. Now I'm going to show you Rti interrupt subroutine, right? Number one, you have to clear the flag bit. Yes, I have to do this one. Number two, you have to count the number of interrupts because I'm going to display one digit every 8 interrupts because I want to, it's 1 second. I want to create 1 second. That's what I did. See here, guys, increment Rti. Now I'm gonna compare Rti to 8. If it is not, if it is not 8, sorry, so if it is not 8 yet, that means I'm gonna come to here and then I'm gonna leave. You can see what I did, guys. So here, number one, I'm going to increment Rti count, right? If it is not 8, just skip this part. So this part is going to be executed every 1 second. Yes, this part is every 1 second. Every 8 interrupts, right? I'm going to come here. Other than that, I'm going to just come increment Rti count, a check, and then come here and then leave, right? Now, every 8 interrupts, what should I do here? Every 8 interrupts. Number one, you have to clear Rti count because I'm going to count for another 8, right? Because I finished 8, I have to count for another 8 for 1 second. This is number one, right? Number two, this is what I told you. I have to display one digit. I have to display one digit. Which digit? I told you, as I explained here, I have to display the digit pointed by X plus count. X is the beginning address, right? As I told you, count in the beginning, it is 0. Every time I display one digit, I'm going to increment count, right? Plus count. That's what I did here. If you look here, guys, what I did here, look here. X is pointing at the beginning address. Count, I put it in A. And now I'm going to take one byte at the location X plus A, which is X plus count, right? And byte X is fixed. X is always here. But in beginning, I'm going to add 0, add 1, add 2, add 3, add 4, add 5. Until count is here, I'm going to bring it back to here, right? So here, I'm going to take A comma X, guys, and then I'm going to read the byte. I put it in port B. So I already displayed, now I already displayed one digit. Now, I'm going to increment the count. Now I'm going to check. If count, I'm going to compare to 10. Once count is 10, I have to make it 0 again. So now I'm going to compare. If it is not 10, do nothing. If it is 10, you have to clear count. Because once we have 0, 1, 2, 3, 4, 5 until here not 9, right? And then after 9, you increment. Now it is 10. So 10, you have to go to 0 again, right? So that's what I did. So here, very easy, right? So number one, guys, if I have to increment Rti count, every 8 interrupt, I'm going to come here. I'm going to execute this part every 8 interrupts. Number one, I have to clear Rti to count for another 8. This is number one. Number two, X should point always at the beginning address here. And then count, I'm going to put it in A so that I'm going to take the byte, I'm going to take the number or the code at the memory location X plus A. I'm going to put it in port B. And now I'm going to increment the count for next time. So every time I display one digit, I have to increment count. But also I have to, once the count is equal to 10, so I have to clear it, right? Otherwise, do nothing if it is not 10, right? So that I can repeat. After 9, I'm going to get 0 again. Any question, guys? Okay. Very important thing here because I think this program has something wrong. No, that's okay. I just confused. No, that's okay. Here is you have to set the time here to 131 millisecond, right? That's okay because we use only. I was thinking about time multiplexing. Here we don't have time multiplexing. I use only one digit. Okay. So now I want to add something also interesting. So this one you have here. You have counting from 0 to 9. Is that okay? So now I can add to this program IRQ, as you see here, guys. This is I can add here in the main program, or you can put it in IRQ, right? I can put here in the main program, guys. I can make counting. I can turn counting on or off. So, but here I put it in the main program. You can use the same code I explained before here to add to IRQ. again, guys, what I want to do, I want to use a push button to turn counting on and off, right? So I can use the same thing to flash. So you can enable or disable RTI interrupts using IRQ here, or you can put this part in the main program. Again, I told you the same task, you can put it in different places, right? So here in the main program, guys, I can put something like that. I'm gonna check if you press a button. Once you press the button, I'm gonna toggle so that if it is on, I'm gonna make it off. If it is off, I'm gonna make it on, counting, right? And so on. So let me show you, we still have 1 minute. I'm gonna just show you the video here. That's it. And then you can continue next time. But let me show you the video here quickly to see how the counting on display, counting on and off. Where is it? Alarm, no, alarm on and off. Oh, sorry, this is chapter 3. I'm sorry. I have to go to chapter 4. Quickly, 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 quickly. No, I have to go to videos. Quickly, quickly. Yes, sorry, just, yes, this one. Look here, guys. So now it's counting. It's counting 4, 5, 6. When I press the button, I trigger interrupt, right? If you put it in the IRQ, right? If you don't put it in the IRQ, you can enable or disable. You can put it in the main program. I already explained the two ways anyway. So I already explained how can you enable or disable RTI from IRQ, or I already explained how can you do it in the main program, right here. So it's up to you. Again, I just want to say it's the same thing. You can do it in different ways, right? So you can put it in the main program. Yeah, here in this part. Here I put it in the main program. So continuously I check. If you press the button, I'm going to toggle and then debouncing, go back to check again, and so on. But if you want to put it in RTI, I already explained how can you do it here. Yeah, here in RTI, every time you press a button, you trigger interrupt, and then I toggle. Toggle here means if RTI is working, I'm gonna disable it. If it is enabled, I'm gonna disable. I'm gonna enable it. Is that okay? That's why you see you can stop counting, because who's doing counting? Don't be confused. Who's doing counting? RTI, right? So once as long as RTI is enabled, counting is working, right? So once you disable RTI, no counting. Okay, guys, that's enough for today. See you guys next time. Thanks. Bye.